One announcement from our friends from VOC here. Please, as this is the radio talk, please switch off all radios that you should have in your hands. Please switch them off. We have interferences with our microphones here and we cannot start the talk. So please switch them off, just as a matter of safety. Before we start, the usual announcements. Be nice to the people of Ziegelei. We want to be welcomed here again. Take away your trash, save water wherever you can, except when drinking it, drink more water. Lower the noise for midnight. We are more than 4,000 guests, 180 villages, 1,000 active angels, thousands of hours already worked. One more announcement. You will see a phone number on the slides for the translation. If you want a translation on DECT, you must dial 8012 8012, not the number that is displayed on the slides, as this is wrong. So it goes. Welcome to our speakers. We will also have a special guest. We all got these famous radio devices, and many of us are keen to get more of them. We will have a talk that will last approximately 45 minutes. Thereafter, we will have 15 minutes of Q&A, and then I will announce a special procedure regarding all of us who want to get their radio. We will have a special procedure that ensures that everyone gets one and that we don't have accidents or manslaughter when going to the point of access. All right, welcome to Sek, RF Guy and Schneider from CCC Munich. Thank you.
All right, thanks a lot.
Thanks a lot.
As many of you might guess, we have been under an immense amount of pressure the last week, so please forgive us if we forget what our slides contain and what we're talking about. We have prepared this presentation today, like a few hours ago. Okay. Many of you, I guess, were at the CCC Camp 4 years ago in Finofurt, and at this camp we had, I guess, the first large-scale rollout of an electronic name badge at a CCC conference. It was the Rocket, and was actually also done by a team of the CCC Munich. And I think many people had a lot of fun with it, and we still see that thing around on international conferences when we travel the world. Every now and then someone has one around their neck, and that's really great because the goal of the Rocket was to have a conference badge which gives people the opportunity to play with microcontrollers, play with embedded systems, and still use it after the conference. That's why we did put on a rechargeable battery and a nice display so you can play with it and have some fun afterwards. Now, 4 years later, we're here and there's another badge. But the fact that there's another badge isn't just a given. I mean, 1 year ago we were thinking about, hey, shall we do something for camp again, an electronic name badge? Yeah, probably, but not a Rocket again, not the same thing again, because we would turn in a circle and do the same thing again and again. We wanted to raise the bar a little bit higher still and have something which has an actual use still after the conference and harvest the opportunity we have to do something like that at the camp. And we are thinking about different stuff, but none of it was really that good. We didn't think that we can come up with a concept which really satisfies us also in learning something and producing a badge which is useful. But thankfully, at the same time, Sek and me, we were working on the Iridium satellite stuff, and we came in contact with SDR. And so we got into that in the beginning of 2014 and worked our way to receiving some satellite data in summer of 2014, and we got hooked. We really thought that SDR is a thing that everyone should play with, and it's not actually that hard to do anything with it. And we came to the idea that maybe it would be a nice thing to have an SDR in the form of a camp badge, which sounded interesting, but also it's a huge challenge. I mean, it's high frequency stuff and all that black magic which is involved. So we started looking around, hey, maybe there are designs which are open source or which are at least somehow accessible, not that complicated, and do something with them. And what we came up with is, okay, so there's the HackerF, and I guess the most prominent member of the HackerF team is Mike Osman, and it's open source, which makes it very accessible, but it's also a quite complex design with lots of parts, lots of also expensive parts, and huge capability though, on the other hand. Then you have these RTL SDR sticks. They're simple in terms of circuitry, but also very limited in terms of frequency range, and you can't transmit with them. And back around in 2014, there was also the portable SDR on Kickstarter. I think it can also transmit, but it's limited to, I think, the lower part of the spectrum. And us as 2B satellite hackers wanted to do something which can also go onto higher frequencies, so we can play with satellites using the badge. So we had a look at the different designs, and we also reached out to the members of our local hackerspace, what kind of contacts they have to chip vendors, because I mean, obviously that stuff is expensive and you have to get support from the chip vendors to somehow donate parts. And we realized, okay, we have a very good contact to Maxim, which is a chip vendor, and NXP, which is another chip vendor, and the HackerF is actually using lots of chips from them, or at least we can replace some of the chips on the HackerF by parts from Maxim, for example. So we contacted them, and it took some time, but we got a very positive feedback from both of them. And so we continued onwards and started to modify the HackerF design a little bit to make it into a badge. And of course, that's only possible because the HackerF design is open source and it's accessible, and you can look at the schematics, you can look at the artwork of the PCB, and you're actually free to manufacture it, modify it, do something new with it, and that's what we wanted to do. And now actually Mike Osman is here. He came to camp after he heard about the radio badge, and he's one of the core members of the HackerF team. And I think he wants to talk to you for a few minutes.
I think it's on. Oh, it's definitely on. Thank you so much. Thanks, guys. This is HackerF1, and it was something that I spent years of my life working on. When I first learned software-defined radio some years ago, I started using it for wireless security research, and I immediately had the thought that more people in the hacker community need to know about this kind of tool and how to use software-defined radio. For all kinds of wireless security research and experimentation and just developing new radio systems. The sky's the limit, literally. And early on, I started trying to give talks at conferences, and I started developing a training program. And to this day, I still teach very often a 2-day, very intense course on SDR that I teach at information security conferences, and I try to help people in our community learn more about SDR and how to use the power of such a flexible radio system for whatever you want to do. And at some point, I started working on the HackRF project, and one of the big motivators for me was to have a platform to use for my class. and to have a platform that people could use to teach themselves how to use software-defined radio and how to do creative things with radio that people have never done before. And I made it open source hardware. I make everything that I do open source, whether it's hardware or software or the content. I'm currently producing a video series that is based on my 2-day class, and I'm putting it online under an open content license. And everything I do is open source. And I want to tell one little story before I hand it back over to these guys. When I designed HackRF, I was able to get some funding to work on the project early on, and a big part of that funding was a beta run. And does anybody out here have a HackRF jawbreaker? Nobody? A few? There's a hand. A couple. HackRF Jawbreaker was the beta board of the HackRF project. It predated HackRF 1, but it's very similar. And the original concept for HackRF Jawbreaker was that we would make several hundred of them and give them away at Tour Camp, the US Hacker Camp. And I was so excited about giving away hundreds of these to a bunch of hackers in a field and see what they could do with them. And then that didn't happen because the project fell behind schedule. And I was so disappointed that we didn't get to distribute them, all the beta boards, to a whole bunch of people who were all present in the same place and talk about SDR and see what people could do with them. And now, years later, thanks to the fact that everything I've done has been open source, this team has been able to take the design and provide you with the radio badge, which is an amazing adaptation. And I couldn't be happier. I am so excited to actually be here when my dream is realized that we are giving now not just hundreds, but thousands of hackers SDR platform in a field, and I can't wait to see what you all come up with. And before I hand it over, I just want to say, because I brought too many of these and they're really heavy, I have Throwing Star Landtap business cards, and I have a lot of them. So if you see me tonight or anytime through the weekend, be sure you grab one of these from me so I have less to carry in my backpack back with me to the airport. Thanks, guys.
Thanks. Thanks, Mike. We're really happy to distribute that stuff, and now comes the part where we actually want to thank someone, and that's the CCC for supporting us and covering the remaining cost of what was left after we got an enormous amount of donated parts from the chip vendors. So lots of RF parts from Maxim, the main CPU from NXP, some transformers and coils from Callcraft, and Infineon is providing the RF switches on the badges. I mean, it's at least, for example, 60,000 RF switches, which is quite a number. Now, we are a team in Munich who has done the rocket badge, so we have a little bit of experience in doing larger runs of electronics. So, and with large, I mean like a few thousand, which for some people is like nothing, but for us it's a lot. And I want to talk a little bit about the timeline. So last summer we thought about the project, and it took us until winter that we started talking to people about it. And then it took another like 1 or 2 months for people to make decisions about if they want to support us or not, which led to an insane timeline, which led to the fact that on Saturday our transporter was leaving from Munich, and on Friday everything was finished. I mean, the last PCBs were falling out of the factory. It was like just in time. It was a very stressful time, but we somehow managed it. I'm still not sure how, but it worked. So we on the way had obviously some fails in the prototypes, and we were running so fast that almost any failure at the first prototype would have stopped the whole project right there, because we wouldn't have any time to spin a second prototype before the production starts. And But the thing was, the first prototypes came back and nothing worked, nothing at all. And after debugging for like 2 hours, we realized, hey, looks like the pinout in that eagle symbol, which is our design program for the PCB, has a problem. There are a few pins swapped, and we didn't know why and what, but in the end we realized, okay, if we drill a 0.25 millimeter hole at the right point of the PCB by hand through to the other side on the back side of the PCB of the chip, we can open up a connection and make it work. And thankfully that worked, and the first prototype started to working somehow, which was almost a miracle. So some advice: read the latest version of the datasheet. Because for some reason NXP decided in February 2015, hey, maybe there's a problem in our datasheet, we have to swap some pins in there. But they didn't update the library in Eagle, and we just used that. So we had to redo that, but yeah, word of advice, look at the latest version of your data sheets. Now, after the first prototypes worked, we had to do a lot of modifications on them, and time was so critical that we had to send off that PCB to the fab house, which was going to produce them, and the lead time was around 4 weeks, and we didn't have any time anymore for a second prototype. So we shipped them off. They were going to be manufactured. At the same time, we started to do another prototype, though, still to verify the layout and make sure that we don't populate bad stuff. Of course, the second prototypes didn't work either. Now, there's a special part in the design, and it connects these two big blue
Ground planes.
Ground planes. This is one ground plane, this is one ground plane. And there's a little piece of copper in the middle of the PCB. You can't see it, it's inside the PCB, which connects these two parts. Now, in the prototypes, they were missing. Somehow the board house managed to delete it from the data set, and we were going crazy. We were thinking that we have to fix 4,500 PCBs to make this thing work. It was quite a stressful night, and I was in the US at that point, driving in the car, having phone conference with Germany and trying to figure out what's going on. Almost going nuts. But it turned out, oh, it's a problem with the prototypes, not with the final PCB, so everything well. Now, therefore, some advice, start earlier than us. It led to crazy stunts to get this thing going, and the lead times for PCBs and components can be really long, and you get pressed hard to make this thing happen. We had to resort to same-day shipments of prototypes just to squeeze out 1 or 2 days to get the fab house happy with the deadlines. It was not good. The stress levels peaked above any sustainable limit. Then another thing, now, okay, everything worked. First prototypes somehow worked. We shipped off the PCBs to the manufacturer, did some second round prototypes, and then the manufacturer of the second prototype says, hey, by the way, your pads for the small components are way too big. You need to change that to get this thing done. And what? But the first one didn't, and now what's going on? And we realized, okay, our layout tool has wrong footprints for the small components there. And you can see that in the picture. In the final board now, we had to reorder some components in a bigger layout package. Therefore, some advice, check all your footprints. Every single footprint, even if you think it's so simple that it can't be wrong and your CAD package has it right, probably it doesn't, and that's what happened to us. Now, that was a little overview. I took part in basically every little aspect of the project and managing stuff, but our RF guy knows the RF parts of our hardware in and out, so he is going to take over and explain a little bit about the hardware.
Yes. So first one was the idea for me. So I know to make a HackRF. It's easy to lay out. We make a very similar design. First one, I use another layout tool as Mike do. So I have put the complete schematic at new. And also we use another controller. We ask NXP, we need a controller. First one, we try to use the same controller as the HackRF. NXP told us, you can get this controller end of this year, something like this. We don't have how many in stock. And then we asked, we can have another controller. And now we have the 4333 with 180 pins. So first of them, we have more I/O pins. So thus we make additional parts. We don't use only a software-defined radio. Also, we like to have a badge. So you need a display. Was also very nice to get ones. This reassembled uses Nokia 6100 displays from a Chinese factory. Was Schneider tried to get them when we get prototypes. Was also a very interesting story to get these displays. By the way, we have the same 5 buttons like the rocket on this part, and also the controller have 2 USB ports. So maybe this is also a nice part. So we add an additional USB port. This is a RF schematic of our radio badge. We look at the components from the HackerF and see there's a chip that have inside a mixer and a voltage-controlled oscillator and a PLL. This is, I think, very expensive. I mean, it's about $60 what the chip cost. And we have this very nice support from Maxim. We have also a VCO PLL controller, so we try to use this. And also I try to find a mixer which have a very wide frequency range. This is from linear, they have about from 1 megahertz, about 6 gigahertz. So we redesigned with another people, this is called Feldweg. With me together, we designed the completely RF part in new. We look over sides what we can get, so we have exchange low noise amplifiers to a Maxim type. We have exchanged the arrow switches. Also, we need the transformers. We have also look this transformers is on USB 3 transformer. Was also works very nice in the application here. So here starts the layout, and then when I sing. This is the layout with an 100-pin BGA. To try to lay out this is a pain, absolutely. The first one say, okay, layout is easy. I make many layouts also in my job, and there is no problem overall to make a layout at this. And so we done, okay. I tried to make 6 weeks, as one was 3 months aligned to get this very nice design. It was very horrible. Now we're gonna finally get it finished. The second thing was, so the second prototype, we asked our supplier, I can make a second round of prototype. Oh, yes, we are on holiday. And within 3 days, I get a new manufacturer. Many thanks to them to get this prototype very fast. And many thanks to them that they say, okay, you have a problem with your footprints. This is not 04 or 02, sondern this is a 03. All done. It's a very nice design. Cost me a lot of time, but it's working. We think we have some errors inside. We have now 44,500 developers. Try to play with the device, and here's a basic error specs. So we have RX and TX range about 50 megahertz to 4 gigahertz. We have to, okay, we make a final measurement of this, so we get a very nice spec to you, but the time running absolutely out. I'm here on the campsite August 2 to get the camp running. Many thanks to the people from Unique to get this project to run without me. We have an 8-bit ADC, this is the same and DAC with about 40 dB dynamic range, and the maximum output power depends on the frequency range, is about 5 to 10 dBm. We have some little harmonics problem from the PLL at frequency above 2.7 gigahertz. And yes, we have to do some measurement, and with an inverse EQ demodulation, so maybe we can shift out some harmonics. The onboard antenna is hopefully tuned. We doesn't measure at the moment at around 2.5 gigahertz. We will do it here at the camp. We make a measurement on the antenna, and this will be around 2.5 gigahertz. But as easy, you can add a standard SME connector and move a resistor. And we also make an antenna workshop that is not terminated at the moment. So I give to Zach. He makes something with usage and about GNU Radio, and we make a live demonstration here. As I many thanks to our team. So to Zach.
Okay, I'm more the software guy, so I'm talking about the software. There's the badge has basically two modes. The one is the camp application, which starts when you turn it on, when you get it the first time. It's quite similar to the Rocket firmware. Actually, we did reuse quite a bit of code. It can display your nick. You can choose your font and animation, same as with the Rocket. Also, we have now a color display, so you can choose the color. You can also display graphics. There are scripts in the Git repository to convert any image to the format that this thing needs. We are working on a web app, so you don't have to do it yourself, but it's not finished yet. Unfortunately, we were running out of time a bit. The second thing is you can use it as an SDR. That's the main thing. You want to play with all the frequency stuff and have fun with it. To get into the bootloader menu, hold the joystick to the left while you turn it on. Then you get a selection of the applications on the badge. Well, one is the camp and the other one is the HackerF firmware. There are two versions on it, HackerF and HackerF Old. The device identifies over USB with a unique ID. And we got a new one, but if you have GNU Radio installed from your Linux distribution, it is too old to know about this, so it won't work with that ID. So we have the HackerF Old, which fakes and says, I'm on HackerF1, and so all the tools work with it. But maybe in a few months, the other one will start to work properly. Then we have two little demos prepared. One is like radio transmission and receiving. So you just boot your badge into the HackerF mode. Which I already did. And then you use a standard GNU Radio Companion FM receiver. So Schneider, do you want to show the other side of the setup?
Okay.
As you can see, as you can maybe hear, let me move this up.
All right. So what we have here is just a Raspberry Pi, and it's attached to this radio here. And we're just looping a file of music through a Raspberry Pi onto the radio. And we're using the integrated antenna, and it's right now running at 2.495 gigahertz, and we're declaring this a scientific experiment, so therefore it's in ISM, no problem. And
some little advice that I forget. When you use to play with SDR, when you use a frequency from 2.3 to 2.7, you use a little power than this mixer. So for experiment, it's a very nice idea.
Okay. Yes, and the radio on Zach's side is receiving the same signal. It's an analog FM signal, and he's demodulating it on his PC right now.
So this is one of the things that you can do. And the other thing is just you can do like nearly every protocol if you know what to do. So we have this remote-controlled power plug. And you can, of course, if you know the sequence it sends, can even turn it on. In fact, it's just a 5-bit address and I think 4 bits for the 4 different power sockets and 1 bit for if you want to turn it on or off. It's a really simple protocol. And of course, it's not documented very well, but you can also listen to it and just press the buttons on the remote control you get when you buy those, and it's really easy to figure out. So that concludes our live demo. And can we have the slides back? Thank you. Now is the call for your participation. We kind of, as you heard from Schneider, ran nearly out of time and produced those at the last minute. And also the software is working, but not very full-featured. We would be very happy if any of you wants to contribute or play with it. So if you do something nice with it, just send us a pull request on GitHub, and we will gladly merge them. Some easy things to do is like you can write loadables and nick animations for the camp firmware. There's this optional RGB LEDs on the badge that you can populate yourself. There's still no ready-made software to turn them on besides some test pattern, I think. Or you could write some games, at least with the Rocket, people did that. You can also modify the firmware itself. We planned to, that's why there are 2 more holes. We planned you should be able to keep your badge this way, but someone needs to write the software to turn the display. And there's some potential to make this badge save power by powering down the CPU when it's not needed that much. Then your battery would last even longer, if anyone wants to look in this. The other part is with the SDR stuff. As this badge has a display and a battery, you can do SDR stuff on the badge. We did not have time to do this. We have a branch in our Git repository which is called Porta, which tries to do FMD code, but we didn't quite finish. It doesn't really work. If anyone is knowledgeable enough and wants to take over or continue, there's a thing called Porta Pack, which is an add-on module for the HackRF, which contains a display to plug into the HackRF, which then makes it like a more improved version of our badge. You can probably steal code from them and implement it on our badge. So there's like FM, receive, transmit, spectrogram, badge-to-badge communication, or even like video streaming to the thing. You can do like 25 frames per second on this display. You just need to get the data to the badge somehow. After this talk, after the Q&A, we are going to give out the radio badges to those who did not get them yesterday. We will have a person next to the exit, which will be the start of the line. So there's no point in racing to our village right now, because if you arrive early, you will just get sent away. Follow this person and you will be fine. If you receive it, please read the included instructions on assembling it. Check the wiki if you have any problems. If you find any problems that are not documented, go ahead and edit the wiki. It's a wiki. Tomorrow we will start with something we call the SDR scavenger hunt, because we want everyone to actually use this thing. We've prepared a few challenges where you need to use it and solve some problems or find some stuff. We will use our Twitter account to get updates to you. There are really easy challenges at the beginning, so everyone can join up. If you're scared, team up with someone. And use of search engines is heavily encouraged. You don't have to reinvent the wheel every time. The starting location will be at our village. You need a radio and some SDR-compatible device like your laptop or an Android with an USB or on-the-go adapter. The end of the challenge will be on day 4 after dark, and the winner will receive some prize. And also on day 4 at 9 p.m. there will be the radio meetup. If you do any cool software modification or hardware modification, we will give out prizes to the coolest of them. And we will also make a photo session so we can document all the cool hardware modifications that people make. And last but not least, we have to spread out the thanks, because people at from the Munich CCC really helped out in assembling all the things, getting the stuff here in time, and a lot of angels helped in flashing them, so they all have software on them and you can just turn them on 2 days ago. And a lot of other friends helped out here and there. You know who you are. If you haven't helped us, it would not have happened. Thank you.
Da ist noch mehr.
Thank you all very much for the thundering applause. You have really deserved it. Thank you very much for this nice, kind and good effort to bring us further in our mission. Before I do more announcements on the radio handover procedure, we want to have about a quarter of an hour Q&A. We have 2 microphones on the top of the aisles here. My guess is we will be able to take 2 or 3 questions from each mic, so if you want to ask questions, please queue up in front of the 2 microphones now. I see people arriving. Okay, we have the first question here.
Hi, my question is, just in your estimation, is it possible to turn the badge into a decked phone?
I think so.
We don't know enough about the protocol, really.
Yes.
And you have to always remember that the badge is it's half duplex, so it can either send or receive at a certain time. And you have a certain bandwidth limit of 20 megahertz, but I don't think that DECT will use that much, unless it's frequency hopping. So it really depends on the specifics of the protocol, and I don't think we're qualified at the moment to answer this question, definitely.
Yeah.
So that's a challenge for the Congress then.
Yeah.
I guess.
Yes.
Oh, so in general, I mean, you have a headset port on the badge that has support for Apple-style headsets, so you have a microphone and some audio output. If you can manage to get the protocol done, you can certainly send or receive DECT calls. Yeah.
Okay, next question here.
Yes. Okay. Thank you for all the work. Really nice. I got one and it's very cool. And now I'm really interested in where I can find Scott. I want to help him with the luggage.
What?
You know? Huh?
Sorry, I didn't get that.
Okay. Where can I find Scott? I'm really interested in one of the hacker refs.
Mike Osman?
You mean Mike
yes, sorry. Yeah.
I don't know if he's
Don't
still
know?
here.
Okay. So
So maybe you have a deck phone, you call them?
Okay, okay. Thank you.
There he is.
Yeah.
So,
I'm going to go when everybody's waiting in line.
Yes. You give.
Yeah. Okay, when everybody's waiting in line to get their badge tonight, I'm going to go walk along the line and hand everybody who's waiting some swag.
Yeah.
So everybody gets something.
okay,
Also-
so we have solved that problem. Thank you. Next question.
Hi, I appreciate your very well-made SDR badge, and I am interested in how software-defined radio will proliferate in consumer and professional electronics over the course of, in the future. Like, what possible
Please
applications?
again, I don't understand you.
What possible future applications of SDR in consumer electronics do you see?
Yes, many of currently devices that you use using SDR, just even a cellular phone have a multi-protocol chipset. This is real SDR. So software-defined radios and many applications will be every more. But you can switch the radio communication just by a software update. This will be the future in most of our devices.
To interject, I think in the end, software-defined radio will take over most of the radio stuff. But from a hacker viewpoint, you can play with everything you see, and that's what interested us the most, not the commercial applications.
Heiko, next question.
First, thank you for making this device and giving it to the camp attendants. And my first question is, I imagine making this device into an approach sensor of sorts. Is it capable of doing radar-like stuff or measuring approach and outputting those values to a computer or another device?
One point is that this device probably does not have the output power to actually do some radar-like stuff. And the second thing is, I'm not sure. I think the fact that it's half duplex will make it very hard to do. You would probably need two devices to do something like radar with it. But we have not experimented in that direction, so I'm not really qualified to answer this.
There is also thing we lost. You don't have a clock input design. You have to make a hardware modification. We have a clock output, so you need a small hardware modification to synchronize two of the radio badges. So we will publish this in near future.
I have to interject. Some of the badges have a clock input.
Yes, we have. Yes, we have a really problem to get the clock generator. We have 3 different versions of this chip on the badges, so we have lucky if one is having clock input.
Okay. Next question.
Hi. Do you have any idea how the HackerF1 compares to the badge in terms of low-frequency applications, like, for example, 30 megahertz RFID sniffing?
Okay, there the HackerF is most likely much better than our device because, first of all, our RF switches are specified from 100 megahertz upwards, and also the low noise amplifiers are specified from 40 megahertz upwards. And also the transformers are more starting at 100. So I'm pretty sure that the HackerF will have a better performance if you go lower in frequency.
Yes. Yeah, even beyond the switch stops also at 4 gigahertz. Even the power, the low noise amplifiers also only 4 gigahertz. They may be working up 4 gigahertz, but you have just try it as a hacking device.
Okay, thank you.
Okay, your question.
This is probably a million ways wrong, but could you technically hook up a ESP8266 chip? It's a $2 Wi-Fi serial module and communicate with a computer with this? Maybe send the video you're talking before, because this chip can handle up to 320 kilobits second audio streaming. Maybe you can figure something out with video or other commands. What do you think?
It's extremely hard to understand the voice.
Yes.
I'm sorry.
Can you speak
Really
up?
sorry. ESP8266, Wi-Fi chip, $2. Connect to it.
Yeah.
You can stream 320 kilobit second audio. Maybe you can stream your video for the board or some other cool things.
I mean, you can certainly hook up such a chip to the radio. I don't see any problem doing that. I'm not sure if it's the point of adding another radio to the radio to stream something. But I mean, at that point, it's basically a display driver. So,
But
yeah.
most geeks only have one badge at a time.
That's true. So that's a good point. So many of you get a badge, and maybe even after the camp, you don't have an immediate use for that. But if you're part of a hackerspace, I'm pretty sure people will come up with a use for these things. So we would suggest that you share the radios with your fellow geeks and come up with projects. Maybe you need 2 of them, but rather have them do something and work on a project than them sitting in your drawer. That would be really great.
Okay, last question.
I wonder if it's probably also possible to watch TV with it, like receive a DVB-T.
Yes, it's already done. Some people told me yes,
Okay.
people already
That's fine.
receive DVB-T with GNU Radio.
Okay.
Yes. Another thing, when we go outside and you grab your radio badge, please have your entrance ticket ready. You need your ticket again, but you get your wristband and your wristband to get your radio, and only one wristband, one ticket, one radio.
Okay, thank you very, very much. Applause.